Let's take a look at question 8.12, which says predict the product for each reaction and predict the products if an acid catalyzed hydration had been performed rather than oxymercuration demercuration. So the oxymercuration demercuration, the first step is mercuric acetate and water. The second step is sodium borohydride, and that is simply a Markovnikov addition of water across the double bond like that. If I had taken the same alkene and treated it with hydronium, so I'll draw out hydronium, and it says to draw the product, so I think it's useful to draw the mechanism for this. So again, the rich get richer, so I'm going to protonate on this terminal carbon here, and I'm going to end up with this secondary carbocation. So there's a secondary carbocation, and then of course that's going to undergo a methide shift to produce this tertiary carbocation, and then water can come in and act as a nucleophile. So I'll draw the curve there for that. There's the nucleophilic attack. Then I get the oxonium, and then via proton transfer, so I'll just write PT for proton transfer. So the proton transfer at the end is going to deprotonate that, and I'm going to end up with this compound. So I tried to draw that bond as straight as possible. So there we go. So this is 2,3-dimethyl-2-butanol. So I'll end up with this compound. But you might be wondering, well, where's the mixture? Well, the answer is, if I take a look at the first carbocation intermediate, some of the water is going to attack that carbocation. So I'm going to get the nucleophilic attack like this. And then I'm going to end up with this oxonium. So I'll draw the oxonium down here like this, and then of course via proton transfer, and I'm not going to draw the mechanism for that step, I'm going to end up with this alcohol. So in this case, if I had treated the alkene with just hydronium, I would end up with two alcohols. So I end up with this secondary alcohol, and I end up with this tertiary alcohol in the red box as well. So again, acid catalyzed hydration in this case will give you a mixture because the carbocation can undergo rearrangement. Whereas if I was to treat the same molecule with the conditions of oxymercuration, demercuration, then I only get one product. So this is why oxymercuration, demercuration is so useful.